Measuring self-assembled monolayers is a two-step process. It's important to measure the substrate before the self-assembled monolayer is present. In this example, I will show you how to measure a self-assembled monolayer on gold. I already have data from the gold substrate open. I'm going to open a blank starting model from the model panel, click Open. From the basic folder, choose blank.mod. We need to determine the optical properties of this gold substrate, and to do so we're going to use a B-spline layer, which is found in the basic folder. Now that the substrate is represented by a B-spline layer, I can click the plus sign to expand, and I'm going to enter a starting material file for gold, which is found in the metal folder. I'm going to choose au.mat, which is a list of N and K values for gold from a published reference. There are several to choose from for various metals. Metal optical properties vary quite a bit depending on process conditions, so even though there are many values listed in the metal library, it's important to determine the optical properties of your exact materials and use these simply as starting values. Now that I have the starting values for my gold substrate entered, I can click Generate, and you'll notice the curves resemble each other close enough I can go ahead and do a fit. After pressing Fit, the software has adjusted the node values of the B-spline layer to match the experimental data. It's a pretty good fit, but I may be able to improve on this by adjusting the node resolution. The default node resolution in the B-spline layer is 0.3 EV. I'm going to see what happens if I reduce this to say 0.2 EV. Press Fit. My MSE dropped from over 3 to about 1.5, and the model curves are a better match to the experimental curves. So I'd say this is a better fit, and it doesn't look like I can improve on it much. I'm going to check the optical constants of the B-spline layer by right-clicking the word B-spline and select Graph Layer Optical Constants. This looks very typical for gold. I don't see any anomalies or any other issues with these results. If I want, I can choose to use KK mode. I can click to turn this on. This will ensure the physical relationship between N and K is maintained. After I turn that on, I need to press Fit again. It'll make some slight adjustments. Again, making sure that the physical relationship between N and K is maintained through the Kramers-Kronig transformation. But the fit result is essentially the same. Now that I have the gold substrate characterized, I can save these optical constants using the layer command Save. Click on the B-spline layer and give it a unique name. Or if I don't need to use them again later, I'm going to cancel out of this. I can scroll down and simply choose Turn off all fit parameters. I want to turn off all fit parameters because I don't want any of these values to change when I am analyzing the substrate with the self-assembled monolayer on top. So I'm going to go ahead and open that data. This is the same sample, now with the self-assembled monolayer on top. If I click Generate, the model curves now are essentially what the data should look like if I had no self-assembled monolayer. Notice the curves are very similar. The biggest change is a shift in delta, which is exactly what we expect for an ultra-thin transparent film on a substrate. To model the self-assembled monolayer, I'm going to use a Cauchy layer. I can add this using the layer command Add. Click above the B-spline. From the basic folder, choose Cauchy, and now I have the layer in my model. Self-assembled monolayers are generally ultra thin, less than 10 nanometers, and we don't have enough sensitivity to determine both thickness and optical constants. So it's recommended to use the default Cauchy parameters, these A, B, and C parameters. Leave them at the default values. That's a good approximation for a self-assembled monolayer. We want to right-click on the thickness to determine the thickness value, and we can go ahead and just press Fit. After doing that, you'll see the software has adjusted the thickness of our self-assembled monolayer, which is modeled here as a Cauchy, to match the data. The result is the monolayer is 3.42 nanometers thick. This is very reasonable. It's what I would expect for this particular sample, and the fit is complete.